Okay, so in preparation for our quiz tomorrow and kind of, I guess, for the world, we are doing a couple factoring quadratics problems, and we're doing these manually. So for this one, we have 3a squared plus 8a plus 4 equals 0. What I want to do is set up two binomials, and I pretty much know that both of my things are probably going to be plus, with two pluses in the beginning, and I want to start out each problem with 3a and 3a. Once you set up your two binomials, there's some scratch work that we need to do. So we need to multiply this number times this number, the a and the ax squared plus bx plus c. A times c is 12. So it's 3 times 4 equals 12. And we need a number that, two numbers that multiply and get us 12 and add and get us 8. So what are the two numbers that multiply to get us 12 and add to get us 8, Rebecca?
6 and 2.
6 and 2, right? So we put in a 6 and we put in a 2. Now for this method to work, we also need to factor out through reverse distribution any common terms that happen to be in one of these binomials. In this case, a 3 goes into both of these. We divide that out. There's no common factors between 3 and 2, so we don't do anything to that problem. This leaves us with a plus 2 times 3a plus 2. And I'm going to check it real quick to make sure that we got it right. So 3a squared plus 2a plus 6a plus 4. And it looks like that's going to be right after we do the math. And then this all equals 0. So if we need to get the zeros of the equation, it's a plus 2 equals 0. And 3a plus 2 equals 0. So our two zeros are a equals -2 and -2/3. That's the first one. We go over here, and the first step to this problem is different. Does anybody know for certainty what the first step should be for this problem? Ryan?
Divide the whole equation by 5.
Yeah, we want to factor out that common term first. So if we have 5 out here, then that leaves us with 5a squared. Nope, 3a squared. 3a squared minus 4a plus 1 equals 0. And then so 3, we use the same method as before, so we want a times c. 3 times 1 is 3, so it has to multiply to 3. It has to multiply to 3 and add to -4. What are two numbers that multiply to 3 and add to -4, Mariko?
-1 and -3.
Okay, so they have to add to -4. And then you said -1, -3?
Yeah.
And I agree with that. Through the method, two binomials, 3a in both of them. It's going to be minus minus, and this also tells us minus minus. -3 minus 1, factor out common terms. We're going to get rid of this 3. And then there is no common terms, we're going to add 5. And then a minus 3. And 3a minus 1. And then we'll check this trinomial real quickly. That's 3a squared minus a minus 3, yeah, minus, did I mess something up? It's 3a squared minus a minus 9a plus 4, but then that's wrong.
Because you divided it by 3.
You divided this by 3.
And you still have negative.
Out, and a minus 1. Okay. That's why we show our work. So then this is a minus 1. So now let's check it out. 3a squared minus a minus 3a plus 1. Yeah, there we go. 3a squared minus 4a plus 1. And then there's going to be a 5 all out there. Same, we're going to have to slide over here to get the zeros. So we have a minus 1 and 3a minus 1. A equals 1 and 1/3. Right?
Yep.